Okay, and good morning. Today what we are going to be doing is starting 5.1, simplifying trig identities. So now what I have on the first page of your notes is the identities you are going to use to help you simplify the trig expressions, I should say. Some of the identities we already know. So the first page and even page 2 on here are just these Pythagorean identities. The identities that we are going to kind of do some substituting in. Like I said, we know some of these. So some of the identities that we know are the fact that cosecant is equal to 1 over sine. We know secant is equal to 1 over cosine. And we know cotangent equal to 1 over tangent. In addition, we also know that sine of theta is equal to 1 over cosecant, because if cosecant is 1 over sine, then sine is 1 over cosecant. Same goes with cosine. Cosine is 1 over secant, just like secant is 1 over cosine. And tangent is equal to 1 over cotangent. They are all reciprocals of one another. Tangent and cotangent, cosine and secant, and sine and cosecant. And this is something that we know very well at this point. We also learned in the last chapter that when we had to use the unit circle points, and those points were at 0 degrees, 1, 0, 0, 1, negative 1, 0, and 0, negative 1, that we had to treat sine as y and cosine as x. And we said then that tangent is y over x. So we have our quotient identities. And they are that tangent is sine over cosine. It actually comes from that idea. Tangent is y over x, sine over cosine. So tangent is equal to sine over cosine, which means that cotangent would just flip it and be equal to cosine over sine. I am not making you memorize these identities. Each of you got a sheet with these identities on them, and I expect you to just use the sheet just as a reference and see what you can plug in and substitute. The last identities we really don't know too much about, or we haven't talked about a lot yet, are the Pythagorean identities. And it looks like my sheet got cut off a little bit. But our first set of Pythagorean identities, and the most important Pythagorean identities, is cosine squared plus sine squared is equal to 1. So anytime I have cosine squared plus sine squared, I can just substitute, cross them out and set them equal to 1, and that's a beautiful thing. Now, if I move over cosine squared or sine squared, what I also find is that cosine squared theta is equal to 1 minus sine squared, or sine squared is equal to 1 minus cosine squared. Like I said, I'm not solving anything. This is just the identities that I'm letting you use, and we'll see how we use them in a few minutes. But our main one here is sine squared plus cosine squared equals 1. Our next identity is tangent squared plus 1 equals secant squared, and cotangent squared plus 1, and that should be equal to cosecant squared. And I don't know why that got cut off either, but I can write it up here. So I'll write at the bottom, cotangent squared theta plus 1 equals cosecant squared. And that's another one of our main identities. Like I said, each one of you has this sheet, and you can refer to it at all times. You can use it on every assignment, every testing quiz. It's not about memorizing these, it's about knowing how to use them. So let's get into actually using them. So we have, for our first example, it says that we are going to simplify the trig expressions below. And basically what this means is we want to simplify it just like we would simplify 15 over 3, or 15 over, when I say 15 over 5. So if we were to simplify 15 over 5, we wouldn't leave it as 15 over 5, we would make it 3. The same is true with these trig expressions. We don't want to leave them in their fit form, like 15 over 5. We want to simplify them. So how are we going to do it? Well, let me start out by actually writing out what we are simplifying. So we are simplifying cotangent over cosecant of theta. And the way we are going to simplify this is we are going to look and say, are there any identities that we can use to put this in terms of sine and cosine? I always say when it comes to identities, all else fails, put in terms of sine and cosine. Put in sine of theta and cosine. Okay, all else fails, put in terms of sine and cosine. So what we are going to do is we are going to look at our identity sheet and we're going to say, how can we rewrite cotangent in terms of sine and cosine? And if you look at your identity sheet, we have our first quotient identities say cotangent is equal to cosine over sine. So all I'm going to do is replace cotangent with cosine over sine. Now let's deal with the bottom. Cosecant. We want to write that. We don't want cosecant in the beginning. We want to put it in terms of sine, cosine, or both. So we're going to look at our identity sheet and we're going to say cosecant, what is that equal to? Cosecant is equal to 1 over sine. It's a reciprocal of sine. And now we're going to say, can we clean this up? Okay, can we clean this up? And I'm going to get rid of this little note at the bottom for us just for some room. So how are we going to do this? Well, I don't know about you, but I always say it's much easier, rather than taking cosine over sine and dividing by 1 over sine, it's much easier to multiply by the reciprocal. So I'm going to keep the numerator the same and just rewrite it cosine over sine. But rather than dividing by the denominator, 1 over sine, I'm going to multiply by the reciprocal, which is sine over 1. If we were in class right now, I would ask you guys, what happens when we have, so now we're left with cosine times sine over sine times 1. If you notice, we have a sine in the numerator and in the denominator. So what I'm going to do is whenever you have something, the same thing on the top and bottom, I always say, what can you do? We can cancel it out. The signs are going to cancel. I'm just left with cosine of theta over 1, which is really just cosine of theta. So this whole thing using our identities just simplifies to cosine of theta. And all else fails, put everything in terms of sine and cosine. Okay? And that is our first example. And our second one's going to follow suit exactly in the same way. Example 2 says what we are going to do is simplify another trig expression. So the trig expression that we are going to simplify here is cosine times tangent. So I'm going to start out with cosine of x times tangent of x. Now a big question I always get is, does it matter if it's cosine of x or cosine of theta? The x, the theta, the angle doesn't matter here. So whatever you prefer, if you like theta and you want to work with that, it's perfectly fine. So let's simplify cosine times tangent. So again, all else fails, let's start by putting it in terms of sine and cosine. So what we see is that we have cosine times tangent. I'm going to leave the cosine of x alone. But I don't want tangent. I want tangent in terms of sine and cosine. So again, I'm going to look at my identity sheet and I'm going to say, is there any place tangent is in terms of sine and cosine? My quotient identities tell me tangent is equal to sine over cosine. So I can just substitute sine over cosine in for tangent. So sine over cosine is replacing tangent. And I'm not going to use theta since we're using x. I'll stick it with x. Now at this point, you're going to simplify this a little bit. The first cosine is over 1. So now instead of cosine times tangent, we have cosine times sine over 1 times cosine. And what happens just like the last one when we have the same thing in the top and bottom? We have a cosine in the top, cosine in the bottom. The cosines are going to cancel, so we're just left with sine of x over 1, which is just sine of x. Okay? So we started with cosine times tangent. We leave cosine alone, but we're going to turn tangent into the reciprocal identity sine over cosine using our identity sheet. We then see that the cosines will cancel, so we're just left with sine of x. And then let's move to our last and final example for the day. So our last example requires another technique that we use for trig identities, and this is sine minus sine times cosine squared. We are going to simplify this. So I'll start and I'll rewrite it. Sine of x minus sine of x cosine squared x. So nothing's really ringing a bell here. Everything is already in terms of sine and cosine. So my next thing I'm going to do is say, what do both of these have in common? What do sine and sine cosine squared, each of the two terms that we have here, so sine of x and sine of x times cosine squared, have in common? Both contain a sine. So just like if this were algebra, what I'm going to do is I can factor out a sine in front. If I pull a sine out of the first term, that was just sine, I'm just going to be left with 1. My minus sign stays the same. My next term was sine cosine squared, so if I pull a sine out, I'm just left with cosine squared x. So what I'm now left with once I pull out sine is sine times 1 minus cosine squared. Here's a trick. So at this point, what do? We have the sine out in front, and in parentheses we have 1 minus cosine squared. Whenever you see a 1 adding or subtracting to a trig function squared, so for example, a 1 minus cosine squared like we have here, 1 minus sine squared, 1 plus tangent squared, 1 plus cotangent squared, something like that, you want to look at your Pythagorean identities. Okay, and remember your Pythagorean identities are on your sheet, but they were your cosine squared plus sine squared equals 1, your cotangent squared, all the ones I just mentioned. Okay, so what we are going to do is look at our identity sheet and see, is 1 minus cosine squared equal to anything? And if we look at our identity sheet under Pythagorean identities, so this is actually a Pythagorean identity, we can see that 1 minus cosine squared is actually equal to sine squared. And then out in front, we still have that other sine. So this equation now is sine times sine squared. And let's take a step back for a second. And if I asked you to simplify x times x squared, you would just tell me that that is x cubed. Sines, cosines, and tangents work the same way. Sine times sine squared is just sine cubed of x. Okay? So the easiest way to do these trig functions is to have that identity sheet in front of you. All of you got a copy. And every time, first, can I put things in terms of sine and cosine? Whenever you see a cosine squared, sine squared, or 1 plus cotangent squared, look for your Pythagorean identities and try to simplify as far as you can. The nice thing with trig identities is they tend to follow basic algebra rules, so you could almost treat sine, cosine, tangent, and reciprocals like they are variables. Okay? So head on over and try your homework. I hope this helps, and let me know if you have any questions at all.